This is the experiment regarding acceleration versus centripetal force, and we are going to use a pendulum to explore this experiment. And we will have a pendulum, a mass hanging from a thread that is connected to a force sensor, and the force sensor can actually measure the tension on that thread and provide that information to you through the capstone data. As for the pre-lab, first we need to analyze this pendulum and see where the acceleration, centripetal acceleration is, and how we can actually calculate that. So when you have a pendulum mass m and you pull this to a certain angle, theta, and you draw the forces, you have the force of gravity on the mass of the pendulum. We assume the thread is massless, and you decompose that into parallel to the direction of the motion of the pendulum and vertical to that direction. So at this point, when the pendulum is all the way to its maximum amplitude, the velocity is 0. So at that moment, there is no velocity. Later on you'll find out it's all potential energy, but we're not concerned about that at this point. So then we let go. The pendulum will swing to the other side and back. In the middle, we will look at the forces acting on the pendulum, and we will see that there is a force of gravity and also a tension of the rope. Obviously, there is what we call a centripetal acceleration towards the center of this semi-rotation, actually. So what we want to find out in part 1, what would be the centripetal acceleration for this pendulum at this point. And all you have to do, just look at the net force acting on this, and from there find out what is the centripetal acceleration. And you need to find that out in terms of the mass of the pendulum, the tension. This tension is captured by the capstone, and you will have that data later. And also acceleration due to the gravity, g. And then the second part, you would plot that versus the pendulum, the tension in the pendulum. Okay? So you would have a plot like this, where the centripetal acceleration axis starts as -10 meter per second squared, +10, 20, and then you have the tension on that side. So this is the part of the pre-lab that you need to do and get those questions answered. And then for the lab itself, we are going to basically take the pendulum and pull it out to a certain degree and let it swing, and we would measure the tension at this lowest possible point here and record that, and then we can also find out what would be the value for the centripetal acceleration. Knowing the length of the pendulum, which is 97.5 centimeter, okay, so you need that number, and you calculate this centripetal acceleration. You measure the velocity from the capstone data and tension, and from there you can, from the velocity, you can find the acceleration. Okay, so this is when you complete this table, you have all the data here, then you plot centripetal acceleration versus the tension at this particular point, okay? And find out what behavior is that plot, and then fit a line or whatever that you think is an appropriate fit to find out what would be the point when the tension is 0. Okay, so that's part of your analysis. All right, so the rest of the lab you have to answer a whole bunch of questions that relates to this experiment and observation and from the data that we will provide for you. Okay, thanks. Okay, so here's our pendulum. Here's the force sensor, and I have a protractor here, so I can pull this every 20 degree and let it go. And when it passes through this sensor, it will register the velocity at that point, which you have in a table, and also it registers the tension in this string via the force sensor. Those are the numbers you need, okay? So, and we are going to do this for 5 trials from 10 to 30 to 50 to 70 to 90 degree, and provide that data to you. All right, thanks.